So this is the third case where, if you carefully see, you do have bar is also moving with the velocity, and there is a magnetic field which is varying with respect to time, right? So in this case, this is here 10 power 60 minus 5. Okay. So in this case, we need to use the combined equation for variable velocity, variable magnetic field. The equation was dB by dt dot ds, whereas for varying it was u cross, this is velocity, this is d dot dl. Okay, so first of all, let me do this particular one. This particular component I will do first of all. If you see this particular component, it is minus integral s dB by dt dot ds, right? In this one, if you carefully see, dB by dt is time differential of 4 cos 10 power 60 minus y into 10 to the power of minus 3, and it has a component z bar, isn't it? So if I do it differential with respect to time, this will become, cos will become minus I, and this will become as a minus 4 into 10 to the power of 6. Already there is 10 to the power of minus 3 already there, into sine 10 power 60 minus y az bar. So this will become 1000. So I can write it as minus 4000 sine 10 power 60 minus y az bar. Okay. Similarly, there is ds component, right? Ds component, this is surface area, so where it is extending in dx dy, so I'll take dz bar. Sorry, this is uz bar, where x is varying from 0 to 0.06 and y is varying from 0 to 0.8. I'm taking them in meters. Okay, so this one will become minus surface integral of dB by dt is minus 4000 sine 10 power 60 minus y az bar dot dx dy az, right? So az dot az is 1, we have already seen that. So minus into minus is also plus, and this surface integral is extended in two directions, x and y, and these are the limits. So I am writing them separately. Y is varying from 0 to 0.8, whereas x is varying from 0 to 0.6, and this is 4000 sine 10 power 60 minus y dx dy. If you carefully see, there is no x term here, so when I am doing with x, I'll take it as a constant. So it is nothing but 1 integral is x. So what I will get here? I'll get only 1, right? So in that case, it is a okay, I'll do it in the next page. So 4000 sine 10 power 60 minus y. I don't have x, so x I'll take it from 0.06, and still I am supposed to do it for 0 to 0.08 in terms of dy. So this component, if you carefully see, it is nothing but 0.06 minus 0, it is 0.06 only. So if I substitute here 0.06 here, what I will be getting? 4000 into 0.06, it is 240, right? 240 sine 10 power 60 minus y into dy, where it is from y is equal to 0 to 0.08. Now you say how this will work. See, there is a y component here, if you carefully see, right? since that is a y component, I should treat it as a sine y. So for sine y, the integration is minus cos y, right? And that is a minus sign also. So I'll be getting plus, right? So it will be 240 cos 10 power 60 minus y. Okay, with the condition that y is varying from 0 to 0.08. So if I substitute it, what I'll be getting? I'll be getting 240 cos 10 power 60 minus 0.08 minus, or if you want, you can keep it just like as a y itself, because if you don't know what is, because nothing has been given here as y variation, so I'll just keep it as y itself. So if it is at 0.08, you can do for 0.08, otherwise you will keep it as y itself. When it is 0, then it will be, right? So this is the expression. Sorry, I forgot that there was no y given actually in this problem. Okay, so this is positive side. On the second side, we do have line integral u dot b, right? U cross b, where u is nothing but 20 ay. So cross 4 cos 10 power 60 minus y az. So we know that ay cross az is nothing but ax. So this will become 2480, and I do have this one, right? So it is dx ax bar. So first of all, I'll get here ay cross az is ax dot ax I'll get as 1, isn't it? And I'll write it here. So it is equal to x is equal to 0.0620. This will become 80. Yeah, this will become 80. And yeah, here 10 power minus 3 is also there, don't forget. Okay, so 18 to 10 to the power of minus 3, it is 0.08, right? Cos 10 power 60 minus y, this is the expression, dx. So what I'll get, there is no x component here, so I'll directly get the same thing. So again I'll get 0.08 cos 10 power 60 minus y into 0.06. I'll get a minus value, that's it. So this is somewhere around minus 0.0048. This is the expression. This is the EMF for the second case. So if I join these two, the net EMF, the earlier case what I have got here, this entire expression, 240 cos 10 power 60, 240 cos 10 power 60 minus y minus 240 cos 10 power 60. This is also to be added. This is my net EMF. If you see, when compared to this one, this is also of similar time, but it is very, very minute. So if you want, you can neglect this one and you can take this one as a total EMF. Okay, that's it for today. Thank you. In the next video lecture, in the next tutorial, we will go through problems on inductances. Okay, thank you.